Hello everyone. This project is developed under course IT 468 Natural Computing under the guidance of Professor Manish Gupta. So this project is chemical reaction simulator. So this allows us to compute mathematical expressions using our chemical reaction simulator. And this also allows us to validate using our own ideal chemical reaction simulator. So to run this program, you have to do python gui.py. Now a GUI will pop up. Now so this has two examples and simulate. So when I click on examples, it gives me two options, basic examples and advanced examples. So let me say I run the decrementation one. So now you have to enter a value. Let's say I enter 90. So this will get decremented by 1. So when I enter OK, I have to enter the time of simulation. Let's say I enter 400 units of time. So now as you can see, a graph is plotted. How is this graph plotted? I will show you the mechanism. So when I enter the decrementation, when I clicked on this decrementation button and entered the value 90, an XML file is created. This XML file contains a set of chemical reactions in this reaction tag and their initial concentration. So as I input 90, the value of the chemical X is 90, and this is the value X which gets decremented by 1, as you can see from the graph. X initially 90, and after this set of chemical reactions are executed, the value of X becomes 89, that is gets decremented by 1. To understand this syntax, let me show you that these are the set of chemical reactions and this is the initial concentration. So here initially this is a first reaction, this is the second reaction, this is the third reaction, and so on and so forth. Now let me make you understand what this reaction means. This means that X plus G on the reactant side gives me 1Y plus 1G. Similarly, I can say that XAB into 1 gives me plus YG into 1 gives me null, as there is no product tag. Let me finally show you this meaning. 2 times X dash plus 1 times G gives me X dash plus XRX plus X. So there's certain chemical reactions after get executed after I input the value 90. After which, to generate this plotting file, a history file is created which shows the concentration of reactants at each time step, and thus using this set of values we obtain this plot. So initially X was 90, its concentration falls, and after a certain time, say 91 time steps, it starts increasing, and after 185 time steps, the value of X gets constant and it is 89. So what we wanted was 89, which was obtained after certain time interval. So now let me implement the incrementation operation. So as you can see, now I have to enter the value which I want to increment. So the first time I press 221, increment 221 file is created. Now I need to simulate it. So if I enter 900 time steps, let me enter 1500 unit of time steps. So as you can see, this history file is created and this plot is plotted. So this plot says that initially X was 221 and it ended with 222. So as you can see, 222, it was obtained after 667 units of time. Here there are certain advanced examples. These advanced examples are coded using the modules of these 4 basic examples. This is implemented. So let me show you the multiplication example. Enter the first value. Let me enter 1, 9, and the second value is 11. So as you can see, this multiply 9, 11 got created. And now when I enter the time of simulation, let me enter 1500 time steps. So as you can see, 9 11s are 99. So after 206 units of time steps, the value of concentration is 99. So thus the final output variable was Z. 9 11s are 99. Similarly, I can implement the power function. Now I have to enter the value, let's say 7. Now the value of exponent is 2. So thus when I click on enter, a XML file will be created. As you can see, this is power 7, 2 XML. Now when I enter the time of simulation, let's say 900 units of time steps. So 7 to the power 2 is 49. So as you can see, initially these are the varying concentrations, after which the value of output variable y is equal to x to the power p is 49. So in such a way we can implement the following logarithm also. But now let me show you how to simulate. Now say suppose if a user has his own XML file, so thus if he wants to run that simulation, so as to know the history and wants to validate the results, then he has to choose the XML file. Let me say I choose an XML file created. Now I enter that time for simulation. Now I enter the reactants which are there in my XML file and which I want to plot. And when I click on OK, this XML file gets plotted. Similarly, the advantage of this is that you can use any XML file and plot the graph. Now there is another function, plot from txt. The txt file has a certain syntax. Before opening a txt file, there are some sample files. Now let me say if I use addition.txt. So this is the value addition, right? Okay, so these are the reactions, these are the initial concentration. Now I want to plot from these files addition. So what I do is I import a text file from sample files. I import addition, I enter the simulation time, and now I want to plot the, after entering the simulation time, I need to plot the reactant. So this is x, this is y, and following my own reaction, I get to know that the output variable is solved in z. So initial concentration of x is 5, y is 5, so the output variable z, that must be 10. So I need to plot x, y and z, okay, from my own chemical reaction. So thus I get the following plot. Now suppose say if I want to save this, so I can save this as addition 5 plus 5, addition 5 and 5, okay. So this gets saved, and now the value of z is 10. So thus in this way we can plot our own XML file, plot our own chemical reactions txt file, and the most important advantage of our software is that it allows us to compute an entire expression directly using a chemical reaction. The chemical, after I enter the expression, let's say 5 plus 7, so the value of 5 plus 7 is 10, right? So I get this XML file, so expression.txt. So this I entered 5, I entered 7, the value of the output variable will be plotted, and this is the plot which I got. 5 plus 7 ended giving me 12. I can enter any expression which I like, but please remember that we have not implemented the parser for the expression. Thus whatever arithmetic sign comes first gets calculated. So if I enter 5 plus 7 multiplied by 8 multiplied by say 9, 12 9s are 81, okay. So first it will compute 5 plus 7, 12, and then it will compute multiplied by 9. So let me run it. So 5 plus 7, okay, sorry, 12 9s is 108. So after 452 units of time steps, this give me the value 108, and here is the chemical reaction that was formed. So in a way, now say suppose I want to compute 5 into 7 into 8 plus 5, instead of computing 5 plus 7 into 8, I want to compute 5 into 8. So I will enter it as, instead of computing 5 plus 7 into 8, I want to compute 7 into 8 plus 5. So this will be, so 7 8s are 56, 56 plus 5 is 61. So the value of the output variable should be 61. So as you can see, for initially certain time the value was constant, and after certain time, say 250 time steps, the value of x4, the output variable, is 61. So as you can see, if you want to see its equation, here is the expression 7, 5 and 8. So any general expression containing of multiplication, addition can be solved using